It's almost impossible to believe, but off the rugged coastlines and beneath the mountainous heart of California, a series of discoveries has sent shockwaves through the scientific world.
New here at 5, there's a large underwater volcano off the coast of California, and scientists think it could erupt soon. But don't worry, they say there's no risk of a tsunami.
From seismic mysteries hidden beneath San Andreas to underwater worlds teeming with life no one imagined could exist, the Golden State has become ground zero for extraordinary new revelations. As the world watches, researchers from USGS, Scripps, Caltech, and international labs are piecing together tantalizing data, seismic pulses that confound explanations, geological anomalies that blur the lines of stable ground, and oceanic chasms holding untouched ecosystems. Drones fly where humans cannot, satellites observe from the sky, and submersibles return from the abyss with samples and footage that leave even the most skeptical geologists awestruck. In only a matter of months, a quiet scientific revolution has begun, one that may shake California and the world to its core. Could a hidden world be stirring beneath our feet and at our very shores, a place where ancient forces and living wonders have waited centuries to be discovered? Is California on the verge of its greatest transformation yet? Chapter 1. San Andreas Fault Anomaly. It starts with a near inaudible whisper beneath the earth, a low, rhythmic pulse drifting through a state built on shifting ground. In late 2025, scientists monitoring the San Andreas Fault began detecting something new. Not the violent jolt long feared as the big one, but a slow, undulating vibration. These low-frequency tremors, repeating every 41 minutes, proved too repetitive to be dismissed as random background noise, and too regular for known tectonic slip patterns. As USGS sensors tracked the anomaly, they realized it wasn't locked to a single region. Instead, the pulse reverberated from the Grapevine near Los Angeles through the mountains east of San Jose, reaching all the way to the Mendocino Triple Junction, where 3 tectonic plates converge. Strangest of all, these tremors occasionally coincide with microquakes across a 350-mile stretch, miniature quakes that seem to hop between distant faults as if following a mysterious underground signal. Caltech researchers cross-examined satellite radar and INSAR data, revealing a faint, elongated uplift, a subtle breathing motion of the land that registered from above, even if imperceptible to those living atop it. The fault appeared to be alive, quietly adjusting beneath cities, valleys, and farmlands. Attempts to explain the phenomenon ranged from seasonal groundwater movements to distant volcanic processes, but neither quite fit. Even less so when similar pulses started appearing near faults farther north in Oregon and in Baja California to the south. Is it possible that the calm of the San Andreas is only a mask, and that something new, perhaps as yet unrecognized in our geologic understanding, is rumbling beneath our feet? Chapter 2. Pacific Abyss Unveiled. California's craggy coastline has drawn scientific curiosity for decades, but in early 2026, a team from Scripps piloted submersibles into the Monterey Submarine Canyon and returned with a find that upended assumptions. They encountered a chasm 130 miles offshore, mapping a sunken valley whose vertical walls plunged for miles, surrounded by intricate forests of shimmering mineral towers, faintly aglow in the abyssal darkness. As their remotely operated cameras explored, they observed clusters of tube worms several feet long, spiraling near mats of bacteria that glowed in geometric patterns. At 12,000 feet, a depth where the pressure would crush most vehicles, life not only endured, but appeared to thrive. The team documented black chimney vents spewing mineral-rich fluids at temperatures above 400 degrees Celsius. Some mineral samples contained rare earth elements and unique isotopic signatures that hinted at volcanic activity, but also suggested an ancient connection to hydrothermal systems, possibly dating back to before the breakup of the supercontinents. Sediment cores from the site revealed microfossils far older than any previously recorded in California's offshore canyons, hinting that some secrets can persist even as everything else changes above. Could this deep canyon's living ecosystem be a window into California's past from millions of years ago? And what does its biological distinctiveness say about the resilience of life? Chapter 3. Earthquake Lights, the Unexplained Phenomenon. As tremors increased in frequency along the Hayward and Calaveras faults in mid-2025, Californians began to witness a phenomenon long relegated to folklore: strange lights in the sky moments before earthquakes. Witnesses described flashes of blue, arcs of violet, and shimmering bands flickering across dusk skies above areas soon to experience minor quakes. Social media filled with photos and videos. Soon, researchers from NOAA and UC Berkeley verified the phenomenon as genuine earthquake lights. On clear nights above San Francisco's skyline, cameras recorded turquoise pulses coinciding with seismic activity, while fishermen on the coast described pillars of light emerging from sea cliffs as quakes rumbled beneath. Detailed analysis showed a pattern. The most dramatic displays occurred where microfractures ran deep and tectonic strain rose abruptly before slip events. Lab experiments offered a plausible cause. Rapid shifting of quartz-rich rocks under strain generated powerful electric fields, which sometimes discharged through the atmosphere as visible light. Are these mysterious glows nature's early warning, or could they represent a phenomenon not yet fully understood by science? Chapter 4. Hidden Aquifers and the Coming Drought. Beneath California's drought-stricken Central Valley and the parched hills of the south, researchers from Stanford and NASA made a revelation in late 2025. Vast aquifers previously unknown, filled with preserved glacial meltwater and sealed beneath layers of stone. Using satellite gravity mapping and AI-processed seismic data, they mapped deep reservoirs hundreds of meters below ground. Some so ancient, they predated the Sierra Nevada itself. The waters, while not fresh, contained rare isotopes and mineral signatures pointing to an Ice Age origin. In some places, networks of aquifers connected through long sealed channels beneath the Salinas basin, hinting at a submerged river system that once sustained life above, but had not seen the surface in centuries. While the discovery suggested the possibility of new water supplies, it brought new challenges. Tapping these deep sources posed a risk of destabilizing land above, potentially sparking subsidence or altering seismic stability. Even preliminary extraction tests indicated that pulling water from these depths sent ripples through aquifer-connected ecosystems, sparking a debate over whether California could safely pursue this solution. Are these hidden aquifers a last hope for drought, or could they set off chain reactions geologists and hydrologists are only beginning to comprehend? Chapter 5. Ancient Faults Resurface. LiDAR mapping in Silicon Valley and Tulare County triggered an unexpected revelation. Not just surface shifts, but the discovery of long-buried faults. Ghost fractures beneath layers of farmland, city streets, and forest. In 2026, detailed scans revealed a patchwork of faint, parallel cracks. Some aligned with the sites of mysterious historical earthquakes that had rocked missions and toppled redwoods in the early 1800s without visible surface rupture. Drilling at these spots unearthed sheared mineral-rich clay, evidence that the cracks weren't shallow features, but real, active faults intertwined with California's seismic story. Even more concerning, researchers found hints of seismic doublets, or paired quakes along separate faults mere seconds apart, suggesting the hazard map of California could be far more complicated than previously believed. Are there hundreds of unseen fault lines beneath our feet? And is science any closer to deciphering the circumstances that may suddenly reactivate them? Chapter 6. Lost Caves of the Sierra. In the granite heart of the Sierra Nevada, amid evidence of ancient glaciers, high-resolution ground-penetrating radar in 2026 uncovered an even deeper legacy. Vast limestone cave systems hidden beneath Mount Whitney and Lake Tahoe. These caverns, some of the largest mapped in the state, extended for miles and contained astonishing formations. Halls filled with crystals and stalactites, rivers of mineral-rich water, and in places, remnants of ancient bone and petrified wood. Carbon dating and sediment studies suggested the caves had been flooded and emptied many times over hundreds of thousands of years. In side passages, cavers found evidence of past megafloods, ancient scratches on cave walls, and microorganisms forming unique ecosystems in complete darkness. Are these caves merely windows on the state's long, dynamic hydrologic history? Or do they contain clues to how California's water systems could evolve under new climate extremes? Chapter 7. Subduction Secrets, Northern California Shift near Eureka and Cape Mendocino. Expanded seismometer networks in 2025 revealed not only shallow quakes, but deeper, slow-moving tremors, slow slip events, originating from the Cascadia subduction zone. For the first time, researchers tracked these tremors in 3 dimensions, mapping waves of energy moving inland from depths of 30 miles, rippling beneath California's northern forests. Above the tremors, GPS stations recorded subtle, synchronous ground movements, changes invisible without precise equipment, but unmistakable across dozens of sensors. Each slow slip event seemed to relieve pressure in one area, only to load new energy onto the locked San Andreas or Hayward faults, raising concerns that quiet movements deep underground could someday prime the conditions for a much larger quake. Could some of the world's most powerful seismic zones be quietly transferring stress beneath California, connecting earthquake risks across hundreds of miles? Chapter 8. Channel Islands' Underwater World. Just offshore from Santa Barbara, robotic submersibles revealed a sprawling submerged plateau near the Channel Islands, with features unseen until now. Coral towers, labyrinthine pits, and hydrothermal vents supporting bizarre, brightly coloured life. High-definition cameras captured scenes of dense tube worm colonies, jellyfish gliding through black water, and glass sponges clustering around sulphurous jets. Chemical data showed waters as acidic as lemon juice, tinged with minerals signaling volcanic activity on the sea floor. Sediment cores documented pulses of volcanic ash and the sudden deposits of freshwater algae, chronicling geologic and climate upheaval over millennia. Fossil layers included bones of extinct creatures, bearing witness to an ancient, long-gone California. Could the seafloors of the Channel Islands be the key to understanding lost chapters of the region's natural history, and clues to what might unfold next? Chapter 9. Lake Tahoe Rift Mystery. Around Lake Tahoe, GPS networks picked up a surprising trend: slow stretching of the land in a process more similar to rifting than classic fault slip. Hydrologists noticed unusual activity at hot springs and gas seeps where new fissures vented gases rich in helium-3, a rare sign linked to mantle processes deep below the crust. When researchers sampled the deepest lakebed sediments, they found layers abruptly changing in mineral content, peppered with partially melted fossils and grains of volcanic glass, evidence hinting at previously hidden underwater eruptions and catastrophic changes in the lake's distant past. Does this quiet rifting signal a new phase in the transformation of the Sierra? And could it mean that the lands around Tahoe are not as stable as they appear? Chapter 10. The Forgotten Volcanoes. While California's Cascade Range attracts volcanic attention, in 2025, teams scanning with LiDAR and satellites found evidence of much subtler ancient volcanoes. Broad, eroded domes hiding on the Modoc Plateau and forests north of Redding. Though dormant for over 10,000 years, these formations showed signs of life beneath. Slightly elevated ground temperatures, faint gas emissions, and subtle earthquake swarms forming halos around their bases. Some peaks registered new thermal signals after heavy rainfall, possibly as water percolated into geothermal systems below, raising the prospect of future steam-driven or phreatic eruptions. Might California's next volcanic eruption come not from its best-known mountains, but from these long-overlooked features rising quietly above the ancient landscape? Chapter 11. Giant Tsunami Boulders. On the windswept cliffs near Crescent City, geologists from USGS and Humboldt State unearthed boulders perched high above modern tides, far inland, and aligned in ways suggesting a force more powerful than normal waves. Beneath the giant stones, sediment contained layers of sea-derived microfossils, ocean sand, and battered shells, interleaved with ancient forest soil. These findings pointed to the arrival of mega tsunamis, likely generated by massive earthquakes or submarine landslides in the distant past. Some boulders may have moved during the destructive Cascadia quake of 1700, while deeper layers encompass events even farther back in geologic time. The evidence is powerful. Catastrophic waves, whether driven by faults or submerged mountains, have swept California's coast before, and may do so again. Chapter 12. Bioluminescent Bays. Each spring, the coves along California's central coast light up with ethereal blue-green glows, but in 2025, the spectacle intensified. While blooms of bioluminescent plankton normally wash in with the tides, researchers from Scripps found not only record densities, but also new genetic strains, some of which appeared to descend from deep-water ancestors. Genetic analysis revealed evidence of mixing between common shallow-dwelling plankton and rare species from abyssal habitats, possibly carried up by powerful coastal currents or shifting upwelling patterns. This surge brought both wonder and questions, as increasing plankton populations led to decreased oxygen in the water, altering which fish and invertebrate species could survive. Are these glowing displays a warning sign of changing ocean conditions, or proof of rapid adaptation by California's marine life? Chapter 13. Deep Quake, the Garlock Fault Awakens. The Garlock Fault, stretching east from the Sierra Nevada, has long been considered quiet. Yet, in mid-2026, a swarm of moderate but deep earthquakes shocked the Mojave region. Unlike more familiar surface tremors, these originated from 15 miles below the surface, releasing energy along stretches of the fault previously considered stable. Seismic networks traced waves of slip, followed by odd aftershock patterns and precursor quakes, all suggesting the fault was entering a new phase of movement. Some geophysicists speculated about connections to shifting pressure from the southern San Andreas, or even deep plate boundary dynamics far to the north. If the Garlock and faults like it are becoming more active, does that mean that California's next major quake may strike from a less expected direction? Chapter 14. Chevron Ridge, Submarine Ruptures. Off the coast near Morro Bay, ocean bottom sensors detected dozens of submarine earthquakes, followed by a dramatic transformation, changes in the speed of sound in the water, and new linear fissures opening up in the seafloor. ROVs found a buried mountain chain split by fresh chasms and plumes of methane venting to the surface. This was the formation of a new Chevron Ridge, a stepped escarpment shaped by repeated fault movement. Samples of fresh basalt and fossil-rich debris suggested a recent, abrupt renewal of the undersea landscape. Swarming lanternfish and cephalopods gathered near the new vents, taking advantage of the sudden, fleeting burst of nutrients and habitat. Does the ever-shifting ocean floor hold the power to reshape California's surface, perhaps in the blink of an eye? Chapter 15. New Life at the Edge. Exploring the San Clemente Basin south of the Channel Islands, a Scripps submersible transmitted images of an unexpected world. Fields of pale anemones, mobs of pink crustaceans scaling black volcanic glass, and a translucent eel unlike anything previously catalogued, darting among vents. Tissue and water samples unveiled dozens of new species, some metabolizing hydrogen sulfide and methane, others resembling ancient evolutionary lineages. Each unique vent system bore distinct microfauna and genetic signatures, a living record of adaptation, survival, and migration, compressed onto a few square miles. Might entire new branches of life be waiting just beyond our reach on the ocean floor? And does the rate of discovery hint at how rapidly California's underwater ecosystems are evolving? Chapter 16. Fault Creep, East Bay's Slow Shift. In late 2025, satellite radar pinpointed a silent drama along the East Bay's Hayward Fault, running through Oakland and Berkeley. The ground was slipping at up to 5 millimeters per year. This creep bent roads and sidewalks, shifted foundation lines, and, in some segments, even sped up after clusters of small quakes elsewhere in the Bay Area. Such slow motion temporarily relieves built-up pressure. However, history shows that phases of rapid creep can be followed by periods of locked faults suddenly failing, leading to damaging earthquakes. Is the East Bay being reshaped by movement too slow for most to notice? And could these steady slips abruptly transform into something far more dangerous? Chapter 17. Tectonic Whispers, Microquake Swarms. In early 2026, the Salton Sea and Imperial Valley became the epicenter of an unexpected seismic event. Vast microquake swarms, where thousands of tiny tremors rippled across the region in just a few weeks. AI processed data revealed that many swarms migrated laterally in sequences reminiscent of falling dominoes, traveling from the Salton Trough to the base of the Chocolate Mountains. These swarms frequently coincided with detectable shifts in geothermal reservoirs and surface emissions of carbon dioxide and other gases, strengthening the link between the earthquake activity and ongoing magmatic processes below the region. Are these microquake swarms merely a way for the Earth to release energy? Or are they early omens of more dramatic motions yet to come on California's restless southern faults? Chapter 18. Salinas Valley Sinkholes. In 2026, agriculture in the Salinas Valley suffered a new stressor. Massive sinkholes, some spanning the width of homes, opening suddenly in prime farmland. Investigations attributed the disaster to decades of heavy groundwater extraction, compounded by subtle fault shifts which destabilized the deep, ancient clay. Excavations beneath the collapse zones uncovered the burrows of prehistoric pack rats, pollen grains of now extinct plants, and artifacts possibly linked to early human inhabitants. Each sinkhole became a time capsule of lost California worlds, and a stark lesson in the costs of mining resources invisibly threaded through the ground. Chapter 19. Lost Forest Beneath the Bay. In a find evocative and haunting, Berkeley researchers probing seismic hazards beneath San Francisco Bay struck preserved stumps, logs, and peat, confirming that a verdant redwood forest once stood where the bay's saltwater now laps. Radiocarbon dating revealed these trees flourished thousands of years ago, before the land subsided and the estuary flooded. Drilling throughout the bay mapped ghost forests beneath the mud, along with pollen and seeds from rare species, marking the site of California's most dramatic land transformations. It's a reminder that not even modern cities are immune to the relentless, patient forces of climate and tectonics. As California's scientists peer into fault lines and ocean depths, caverns and canyons, the discoveries keep coming, each more astonishing, distressing, and inspiring than the last. The earth whispers, the water glows and surges, the ground sinks and opens. The answers bring more questions, yet one truth shines through. Beneath our cities, farmlands, highways, and breaking surf, the Golden State holds worlds waiting to emerge. So the next time a tremor rattles your window or a midnight wave glows blue, ask yourself, what secrets are still trembling just beneath the surface, waiting to be discovered. What story of California will rise next, not in the morning news, but from the deep earth, the restless ocean, and the ever-changing unknown?